And this is the symbol for transformer over there in the corner. Schematic diagrams. What kind of diagrams we have? We said it's very important for us to read diagrams. The book has some diagrams here. Let's look at them. Again, as Henry said, that we will need to know the north. We need to know where we are in the diagram. So they vary from very simple one. Installation diagrams are the easiest. They just tell you connect wire 1 to wire 2, wire 3 to wire 4, and so on. Those are called an installation. There are some also factual diagrams. Those ones you don't want. You have too much information on it. It's kind of, you don't need all that. So, you know when you in Google Maps, you can have more details and less details. What do you want to know? You want to know the streets? Where are you going? Do I want to know traffic lights? No. Do I want to know how many pedestrians in the street? No. Do I need to know the building? It becomes very overwhelming. So you need to know some certain things, and the more information you have, the more overwhelming it gets. So that's the fact. That's the factual diagram that has a lot of information. What we need is the installation diagram. So schematic diagrams, most useful and easiest to follow. Tells how, when, and why system works. Includes symbols and line representation. Pictorials. Those also called the ladder. The ladder diagrams have line voltage. Show you the components of the blueprint. Where are they located? The factual, that's the one that's overwhelming. There's a lot. Imagine if you have a map with the elevation of every street, with every street light, all the bad neighborhoods and the good neighborhoods, and also that you need to know. Like, there's a lot of things that you didn't need to know. So there's a lot of information. Every restaurant, every shop, it's too much information that's going to take away from knowing the actual connection. But if you're a real estate agent, that's very useful to you, right? Like you want to know the elevation, you want to know the flood line, you want to know the gas line, you want to know how far are you from the transformer, and so on. So for us, we are trying to get just the installation. If you were to go into troubleshooting, that's when you need to pull out the factual diagram and see what's going on in there. If you were to fix the control yourself, again, you need more details to know the map inside the control. But for example, I will need to know all this. So if I were to have the installation diagram, I will only have the connection for all those terminals. That's it. You'll tell this goes here, this goes there. I don't need to know anything inside of here. But if I were to do troubleshooting, I need to know all the connection and how where they go. So that's the main difference. Installation, again, is very general. Very little internal wiring. That's the main key point. And again, if you get overwhelmed, just go get a marker and cover everything inside and look where the terminals outside are going. Find your box and look at the wire coming out of outside of it. Terminals, wire size, color coding. We didn't need to do the wire sizes and the color coding, breaker or fuses. We don't need to know all this information. All we need to know which terminals goes to where. I'll show you a real life wiring diagram as simple as it gets. This is a primary control, and it has the installation diagram right on it. It is very lean. It has the basic information. We do not need to overthink it. That's the installation diagram. So what is this here? That's the component you're trying to install. L1, black wire coming from L1, which is what? Hot, right? Red line is connected to L1 as well. So same thing. White, neutral. Valve is a violet coming out of this box, or the valve, the neutral. Burner motor, orange, neutral. Blue, neutral. Cat cell goes to cat cell. TT is thermostat, and we're done. Simple as that. We did not go through the inside. We do not see the relay. We do not want to see anything else. This is the box as it is. These are the wires with the colors. Don't complicate things. And you know already that every wire that goes to a component needs what? A neutral. Otherwise there is no circuit, it's not going to work. Alright. Another schematic here. So this called also a ladder diagram because it looks like a ladder. We have L1 and L2 component connected to it. I highly doubt you'll see something like that for installation, but this tells you how the equipment is actually wired. This is the whole control for air conditioning unit or a fridge. These are the contactors with the relays, compressor fan motor connected in parallel, crank case heater. Again, look at the legend, it tells you what everything is. And here, what is that? Everett. Transformer. Which means, as Jesus said, this is 120. What is this? 24. So this is my controls, 24. And these are the low and high pressure switches. And this is my thermostat. So Bill will walk you through how to wire the R, G, and Y for a thermostat. But that's basic control schematics. Some symbols. Is that a heating or cooling thermostat?
Heating. Which one?
It is a heating. How would you guess? They're both thermostat. It's a heating thermostat. So remember this. When things get cold, they shrink. So if this is cold, it's going to shrink and it will activate a circuit, which mostly going to give heat. So it's a heating thermostat. Is that easy to remember? Think of it logically. And this is a cooling thermostat. When the system is hot, this will expand and complete the circuit. And since we're too hot, this is going to operate a cooling circuit. You might find both in a one wiring diagram, especially for the AC. You have a defrost cycle and you'll have a cooling cycle. What about this? This is high or low pressure switch?
High.
Huh?
Say high.
What do you think? So if this is the pressure sensor here, this is a low pressure.
Yeah.
Low pressure. If the pressure is low, it's going to be pulled in and cut out the circuit, and the opposite will be from the bottom. Similar to the thermostat. Regular switch, double pole switch, two things opening at the same time, magnetic starter, fuse. You don't have to remember those things. Those things, they have what looks like a coil, are relays. This is the contacts, normally closed. Again, when in doubt, you can look at the book, schematic, look at the legend. All right. Not to scare you or anything. No, don't be overwhelmed. It's just a lot of rubbish. Once you go with a marker and clean things up. So what do you need to know from here? Do I need to know all this inside? No. I'm gonna cover all this. I don't need to know anything about that. Is there anything connected here? No. Do I need to know about this relays? No. I don't need anything inside. All I need to know is those connections in here, and that's it. So this is all extra information that I don't really care about. What's coming out of this box? Black, 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 line voltage. Another line voltage, three phase. Another black and neutral. So we know it's a three-phase AC. White is neutral. Another three-phase is going to the motor. So this motor is going to be three-phase. I don't even have to wire the motor. It's wired already. This is my wiring, and it's going to go to the disconnect switch, and that's all. That's all you have to do. I do not have to deal with any of that in the outside, in the inside. But it's useful. Somehow they found out that this is important for you to know what's inside a motor. Okay, fine, whatever. But I don't need to know all that. So the less stuff you cover out, the better. And I do that for most of the lab controls. I cover up all the stuff so it does not overwhelm me. Just look what's coming out. What am I supposed to do with a connect with that? Don't get very overwhelmed. All right, let's do a quick Recovery. What's a contactor? Lance.
Opens or closes sets of electronic contents by action of solenoid coils.
Okay, what is the difference between a contactor and a relay?
Size and amps.
Size of amps. De-energized. No power. Disconnect switch. Yeah. Energized. Power on. Closed. Factual diagram. Something we don't need too much information. Fuse melts when we exceed amount of voltage. Heater produces heat. It's big resistance. Installation diagram. That's what we need. Where each wire goes. This is installation diagram. Very concise to the point. Load. Anything that consumes electricity. Magnetic overload. Whenever you exceed the load, it will cut off the power. It's a contactor, which also a relay, that if we exceed the power that's rated on the magnetic side, it will trip. Motor, it rotates. Small equipment that rotates, it consumes power. Normally, de-energized. Normally closed, when it's de-energized, this relay is closed, it's normally closed. Normally open, usually when it's de-energized, it is open. Pictorial diagram. It's a combination between installation and a factual diagram and a ladder diagram. You don't need to know about that. Pole. Pole is the line of action. I might as well explain that. So, if this is a coil, pulling two relays, one of them is normally open, one of them is normally closed. When this is energized, what will happen to this one? And this one? Open. So that's double pole, two lines of action. Two lines of action, double pole, and also this one is double throw. Because, again, two lines of action and two different actions happening at the same time. If this was, so this is going to be double pole, single throw. So the pole is how many connection is there, and the throw is what is it doing. I'm trying to say that in different terms. Question?
It wasn't really why is it, I was told it was P-U-L-L, or not really told, but I've always thought it was P-U-L, like pull something.
Yeah.
I've always thought of it like that, so when it closes, it's pulling power to that.
Different implementations and different book and different industry. Again, stuff you'll see here, you'll see differently in different, if you did electronics, they call things differently. They call, for example, neutral, what do they call it? Common, for example. You'll hear that. It's the common. We call it neutral. You can hear it's common. They have different names and different mutations, so don't be alarmed.
No, I didn't know if it was just a wording thing, or it was actually like two different terms for the same thing.
It could be two different terms for the same thing, as far as I know. Pressure switch, push button switches, relays, schematic diagram, signal lights, and solenoid. So we covered these terms in the last 2 weeks. Again, as we work with them, we will be more familiar with what they do. And again, these things, no matter how much you talk about them, until you work with them a little bit and do some mistakes, they do not stick as much. So if you feel it's a little bit too much, that's okay. We'll work on them more and more. But there are some things you have to kind of solidify: hot, neutral, compared circuit, resistance, ground. Those things you have to know for your own safety before you do any kind of connection. All right, I'm good. Any questions?